this lesson, we're going to be multiplying polynomials using that product rule that we learned in the last lesson. So let's first start by just reviewing what we learned last time. If we want to multiply things with exponents, we add the exponents. But we can multiply in any order, so first I would do 4 times 3, which is 12. And then x to the 4th times x to the 5th is x to the 9th. Again, I'm adding the exponents. So if I want to multiply a monomial, something with one term, by a polynomial, I can use the distributive property to do so. Again, remembering that I have to add the exponents. The first term here would be 4x and then y to the 3rd, because 2 plus 1 is 3, minus 4y to the 4th, I added the exponents, plus, let's see, 4 times 2 is 8, and then we get an x, y to the 5th. Now, if we want to multiply two binomials together, we have to distribute every possible combination of terms. So I would start by multiplying the x times the x minus 2, and then I have to multiply the 3 times the x minus 2. That would give me x squared minus 2x plus 3x minus 6. And finally, I would combine those like terms in the middle. Minus 2x plus 3x is plus 1x. Now, when you're multiplying two binomials, there's actually an acronym, FOIL, that you can use to help you remember all of the distributing that has to be done. This acronym stands for FIRST. So we start by multiplying the first two terms together. In example C, 2x times 2x would be 4x squared. The O stands for outer. The outer terms are the 2x and the 4y. If I multiply those together, I get 8xy. The I stands for inner. That would be the minus y times the positive 2x, which would be a minus 2xy. And finally, the last two terms, the minus y and the plus 4y, would be a minus 4y squared. Finally, just like in the previous example, I'm going to combine some like terms. Those two terms in the middle can be combined to be a 6xy. So anytime you want to multiply two binomials, you can use this FOIL acronym to help you do so. Example D, the first would be 15x squared. The outer is minus 36x. Inner plus 20x. And last is minus 48. Once again, I combine like terms to get my final answer, 15x squared minus 16x minus 48. Now, if you want to multiply a binomial by a polynomial, like in example E, I don't have an acronym to help us remember this. We're just going to have to write this out the long way. We're going to multiply the x squared by the x to the 3rd minus 4x plus 2. And then we'll multiply the 1 by all three of those terms. So multiplying the x squared gives me an x to the 5th minus 4x to the 3rd plus 2x squared. And then I multiply everything by 1, which doesn't actually change any of the terms. Finally, I finish the problem by combining like terms. And the only like terms we have would be the minus 4x to the 3rd and the plus 1x to the 3rd. Those add up to a minus 3x to the 3rd. There are no other like terms, and so my final answer is just a polynomial with 5 terms in it. Now, there are a couple patterns that come up when you're using this FOIL process. For example, if you multiply y plus 7 times y minus 7, using the FOIL process, you would get a y squared minus 7y plus 7y minus 49. And in this case, when you combine like terms, those middle two terms add up to 0, and you're just left with y squared minus 49. Rather than writing all that out, for most people, it's easier to just remember that pattern. Anytime you multiply two binomials that are identical except for the sign in between them, you always get a difference of perfect squares. I have the formula written down in the notes, and I'll show you how this works with example 3. So 3x minus 4, 3x plus 4, that fits into this pattern. The a would be the 3x, and the b would be the 4. The This pattern says we're going to get a difference of perfect squares. We can, in other words, square the first term, and we get 9x squared. And then we square the 4 and we get 16. And so our final answer is 9x squared minus 16. Now, it's not wrong to use FOIL on this if you have a hard time remembering this formula. But in some cases, especially when you have fractions like in part B, this pattern is going to save you a little bit of time. So part B also fits into the pattern. We have the exact same binomials. The only difference is the sign in between them. So using the formula, we can square each term and subtract them. And that would give me x squared over 9 minus y squared over 4. Now there is also a formula for squaring a binomial. But for some of you, it might be easier to just use FOIL on these problems. I'm going to do 4a using both methods, and then I'll try to show you the formula in parts B and C. So x plus 7 squared, what that actually means is we're taking x plus 7 and we're multiplying it by itself. Using FOIL, I would get x squared plus 7x plus 7x plus 49. And if I combine like terms, that becomes x squared plus 14x plus 49. Now, this formula I have in the notes is basically saying that if you want to use a formula to square a binomial, you will always get the first term squared, so that's the x squared, plus 2 times the first, which was x, times the last, which was 7, plus that last term squared. And that becomes x squared plus 14x plus 49, which is the exact same thing I got when I used FOIL. Again, I think most students might find it easiest to just use FOIL on these problems, but I did want to point out the formula because some of you, if you have a good memory, you might find this formula a little bit faster. So if I wanted to use the formula in part B, I would take the first term squared, so y squared plus 2 times y, and then this time I'm going to say that b is a minus 4 plus minus 4 squared. That gives me y squared minus 8y plus 16. Negative 4 times negative 4 is a positive 16. Again, this problem could have also been done by writing this out as y minus 4 times y minus 4, and then when you use FOIL and combine like terms, you will get the exact same answer. All right, let's do one more example. Using the formula 5x minus 3 squared, we would take the 5x and square the quantity plus 2 times the 5x times the minus 3 plus the minus 3 squared. That's what the formula tells me. So that becomes 25x squared minus 30x plus 9. However, it's never wrong to write this out and use FOIL. That will give you the exact same answer. The thing to remember is that when you're squaring a binomial, you can't distribute the exponent. You have to either use the formula or use FOIL. Now, I don't have a formula for cubing a binomial, so instead, you are going to have to write this one out. X plus 2 cubed means you're multiplying x plus 2 times itself 3 times. Again, you can't distribute the exponent when you have a sum or a difference. This is a really important thing to remember. This is the kind of thing that you don't get any partial credit for. You have to write these problems out. To multiply 3 things together, you can start by just picking any 2 of them and multiplying those together. So x plus 2 times x plus 2, I think I'm going to just use FOIL on that. And if I combine like terms, I get x squared plus 4x plus 4. To finish the problem, I'm going to have to multiply x plus 2 times that trinomial. So that means I have to distribute the x and distribute the 2, and then combine like terms. So I went through, I multiplied the x by all 3 terms, adding to the exponents, and then I multiplied 2 by all 3 terms, and then finally, if I combine like terms, I will get my final answer of x cubed plus 6x squared plus 12x plus 8. So the important thing to notice is when you have exponents and you have sums and differences, you really have to write everything out and use FOIL. Unless you're squaring something, then you're welcome to use the formula. But I would actually just recommend using FOIL. I think it's fewer things to memorize. So I've got one more example to show you. Negative 3x squared times 2x plus 1 squared. The very first thing I'm going to do is write this out. 2x plus 1 squared means I have 2x plus 1 times 2x plus 1. To multiply three things together, you start by just picking any two. I'll pick the second two and use FOIL. And so if I multiply 2x plus 1 times 2x plus 1 using FOIL, I end up with 4x squared plus 4x plus 1. And then finally, I'm going to distribute the negative 3x squared. And that gives me negative 12x to the fourth minus 12x to the third minus 3x squared. Now the order you multiply in doesn't matter. And so I'm going to do the problem a second time. You don't have to put this in your notes. But I do want to show you, you could multiply the first two terms together instead. So distribute the negative 3x squared to the 2x plus 1. Notice I only distribute to the first parenthesis. I'm basically just multiplying two terms together, and then I take the result and I multiply that by the third term using FOIL. And if I use FOIL and combine like terms, I end up getting the exact same answer. All right, that's it for this lesson. As always, let me know if you have any questions on this material.